Thank you. Welcome, Vilnius, to the Dev Days Europe and to our talk. It's all about AI, yeah, promises and challenges in computer vision and NLP. So, before we start with our talk, we want to introduce ourselves.
So, my name is Thomas Endres. I studied computer sciences, and after my studies, I joined TNG. I've been here for 30 years, and now we're gonna present to you the best of our innovation hacking team. And
Innovation hacking.
with me is Martin.
That's amazing. My name is Martin Förtsch. I've studied computer sciences and applied sciences. I'm working for TNG since 17 years. But we don't talk about us. We want to talk about AI. So this is our innovation hacking team. So in 2013, we started to control drones, quadrocopters with bare hands. Then we built a Terminator vision with which you can see the world through the eyes of a Terminator, gesture-controlled robots and stuff like that. We also made Star Wars-like telephone calls with HoloLens and Kinect, you name it. So just using top-notch technology and doing crazy things. But Thomas, why do we do that?
Yeah, there are three reasons why we do this. The first one is to gain new skills. Of course, if you want to be bleeding edge, you need to train those skills and you need to play around with these technologies. But we also want to inspire people. So this is why we are here today, to give you new ideas for projects and things like that. And the last reason is, of course, because we can, because it's possible, because we really love technology. And this is why we want to do this.
But let's assume there is somebody having an idea for a business project. What should they do?
Yeah, just the project.
Okay.
All right, then let's go on.
So I have a question to the audience. So what has this picture in common with this one? Sorry? AI generated. Awesome. That's perfect. It was generated with Midjourney, a text-to-image AI. And here I used the prompt Obi-Wan Kenobi as a oil painting. In this one, I used the prompt Jesus in front of a steering wheel of a Ford Mustang. And here you might guess what this could be. Boris Johnson with a Pinocchio-like nose. And but we have another one, this one. Jesus winning a dance battle against a super devil in a moody black hip-hop mosh pit. Yeah, with dynamic lighting and you name it. So this is actually what AI can do today, text to image. So the innovation hacking team shifted their focus, as you might notice. So we had those 3D cam stuff and so on, but now we are focused on AI for several years. And let's have a look now to the agenda. What can you expect today? We want to have a look into artificial intelligence. We want to show you some computer vision demonstrations, live examples, and but it's a firework of live demos today. Neural real-time style transfer, real-time deepfakes today, and a shitposting AI, whatever that is, we will see. Yeah, so artificial intelligence, machine learning, what is the difference? We thought to show you artificial intelligence with its old meaning from the 50s. Let's have a look to this one. So 1966, Joseph Weizenbaum implemented a chatbot. Actually, this is Eliza, and this is one of our first demos. So let's have a look here. So Eliza asks me, hey, is something troubling you? So I type, I am quite happy. So create output. And she says, can you explain why you are suddenly happy? Then I say, I don't know, because. And create output. And then it says, is that the real reason? And so on and so on. So some of you probably already know Eliza, and believe in me, within a few minutes you will identify this thing is totally dumb. And the question is, why is this the case? So let's have a look. If you have a look under the hood of Eliza, if you have a sentence like, I must say you are a robot, if you say that to Eliza, what happens here? The sentence gets somehow divided into different parts. And you can match the user input to a specific rule. So in other words, it's just something like some if-then-elses. You are just mimicking human behavior. And in the rule array of strings, you see something like star, you are star. And what can you do right now? For this matching rule, you just look to some answers. There is another error. You pick up the response line, and then something like this happens. Does it please you to believe I'm a robot? Yeah, back in the days, people thought this can replace a therapist. Yeah, okay. In the 80s, we had machine learning mimicking human behavior, but relying on patterns. We will show you something later on. And since 2006, deep learning. So relying on deep neural networks. And this is what we are talking about today. And then after the invention of that, it was really crazy what's going on. And also like ChatGPT for 2022. So the question we ask ourselves, regarding the evolution of artificial intelligence, which path do we go? The red one, the yellow one, or the green one? Yeah, brace yourself, winter is coming. Or maybe it's more this one, the summer. Yeah, we will see. Now let's start with computer vision in a nutshell, Thomas.
Yes, of course. So before we had all these crazy neural networks, we had other ways of identifying faces, for example, and just telling you where a face is located. And this is based on so-called Haar cascades. So Haar cascades basically take the picture and they try to fit in some features. So if you have a look at the next one, there will be features like these edges, these lines, or also these ones that go from the top left to the bottom right. And you could just put them on the face. So for example, if you have the eyes, they might be a horizontal line, or the nose might be a vertical line. And then you can do some classification based on that. So you learn, then there is a learning mechanism in there which learns how the specific different features fit into the face, and then you can classify whether this is a face or whether the pixels that you are seeing are not a face, because you see things like horizontal lines and vertical lines which are connected in a specific way.
Right, and the interesting part here is that those features, remind this term, these features are hard-coded. And we have a live demo on that.
So let's have a
How
look
surprisingly,
at that.
so many live demos today, and let's start with this one.
Yeah, so Martin is now in front of the camera, and now you can see, actually it recognizes two different faces. And as you can see, once there's a small disturbance, it loses the face of Martin. So it doesn't recognize Martin if he's looking to the left or to the right or something like that. So these Haar cascades are still pretty dumb in that they don't really recognize the face, but just some visual shapes in there.
Yeah, and this brings us now to deep learning in a nutshell. So let's go back to school. So this is the human neuron, and there is something really interesting when we have a look to that. So if you might remember, a human neuron can have an activation potential, and if it exceeds a specific threshold, there will be an action potential on the neuron, right? Yep. So there is a stimulus, the stimulus goes in, and we have the action potential, or we don't have it. So you could say 0 or 1.
Yeah, it fires or it doesn't fire.
Yeah, right, it fires or,
yeah. Yeah, and there was some crazy mathematician who thought, hey, this could be a mathematical model.
Yeah, let's put that into a mathematical model, right? So we have on the left side XO, which is could be just a number, yeah? And when it goes into the artificial neuron, we just multiply a weight omega 0 to that. And inside the neuron, we can add a bias, if you like. And then there is the activation function, and which calculates the final value, the final number, and then it gets forwarded to the next layers of neurons. So we took all our money and made this beautiful simulation here. You can see 3 different inputs, and with the omega weights here. And so if the omega value is below 1, it gets a little bit smaller. If it's greater than 1, vice versa, you name it. And inside the neuron, everything gets summed up, the bias, and so on and so on. But now we want to know what has this to do with face recognition, Thomas?
Yeah, so here you see the picture again, which we had with the Haar cascades. So we can now just put some grayscale values on that. So here you can see white pixel is a 1.0, a black pixel is a 0.0, and everything in between. And then you can just take the picture and take it line by line, just put that on a string and use this string as an input. So, and this is our input vector into our neural network. And our neural network is layered now, so it has different layers, which means that our input vector is connected to all the neurons of the first layer, and then this is connected to the second layer, and so on, and so on, and so on, until we get to the final value, and this is our output, where we say this is a face or this is not a face.
Right. And the best part about that is if you train a neural network on faces, those features, they get created while the training, so they are not hard-coded by humans. This is the interesting part. So let's assume we have this picture of a duck here, and now we put that in our trained neural network, and yeah, now it says, okay, I'm confident just for 23% this is a face, so obviously it's not a face, so that's quite perfect. But what happens if our deep neural network says, hey, this is a face? This would be our reaction, and it would mean for us, okay, we have to retrain, we have to train further, yeah? So it's actually not good enough. And the interesting part is, how does that work? So we have typically, when we train deep neural networks, we have training data, so-called labeled data. So we put pictures in where we definitely know it's a face. So here is face is 1.0. And we assume our deep neural network says, yeah, I'm quite sure 82% this is a face. Then we can calculate a cost function. So in this case, you take the 1 minus 0.82, then you square that so that errors don't eliminate themselves. And then you can see that there is a quite small number of this cost function, which is quite good. And let's have a look if we put in a duck, which is obviously not a face, and it's still saying I'm quite sure that it is a face to 82%. And then you can see that the cost function value is much bigger. And this is actually how you can use these cost function values to punish your deep neural network all the time till it's doing the good stuff, the good things in the right way. And for this, you have your, as I said, the loss function and then the optimization methods, gradient descent, and so on and so on. And just think of a huge machine with millions of synthesizer knobs where you can just turn the knob in different directions to fine-tune. But the problem is, of course, humans are not able to control that. So actually, this is why we are training. Okay, so live classification would be our next demo.
So
and
let's
this
try
is
that.
probably the reason why Thomas just picked up a bottle. So thank you. And may I ask you to bring me the coffee mug here? Okay, thank you. So let's have a look. I place this here, and you can see water bottle, 80%, 90%. Awesome. What if I remove it? Ah, a lab coat. Awesome. A Windsor tie. I don't see that, but anyway, good enough. Here, drink something. So. Yeah, it's
Band-Aid. Okay.
It's not that good, but actually you can see we are using VGG19 in this case, which is not really good, but quite efficient. And to sum it up again, what you learned right now is that in the first layers, you typically identify more simple features, and the deeper you get into the layers, the more complicated the features will be. So the shapes of those features. And in the output layer, you hopefully have those activations which then match for the cat if you put in a cat. And you can make those features visible. And this is something we call a deep dream demo. And for this, Thomas, do you want to? I'm the model. Okay.
You go ahead. So what Martin now does is we take a picture and then we try to apply that through the neural network, and we make each and every feature that you see. So first of all, the initial features, so the basic features, you can now see them. And the further we get into our deep dream, the more vivid the hallucinations get. So we are getting deeper there, and then you see some animals in there, so some weird animals actually. But you can also see on which data this neural network was trained. So it was basically, so there were some animals in there, there were some nature scenes in there, and the deeper we go, and we are getting abstract, more abstract again, and so on and so on. So this is what the neural network is thinking about internally.
Thinking.
Thinking.
Yeah, so this brings us to the next demo, the neural real-time style transfer. So let's have a look to this picture. So who draw this painting? Van Gogh. You're awesome. Very good. This is Starry Night. And who made this photography? Actually, it was me. So this is the Mesa Arch in Canyonlands, USA. And let's have a look to this transformation here right now. So actually, it looks like that Van Gogh just visited the Mesa Arch and painted it in the style of, the Starry Night. So in fact, what is a style transfer? Yeah, it's something like a pastiche. So you take this input photograph and you extract the style of the painting. You add that to the photograph, to the content, and then you have the pastiche where you still can see the content, but with the style of the painting. If you want to try that on your own, deepart.io, this is the original inventor who, invented style transfer, in fact. And for these neural network, you also have to make use of coast functions again. So there is, of course, the content loss. There you just have a look to the same pixel positions of the original input photograph and the iteration of the style transfer. And of course, they have to look a bit different. That's clear because it's a style transfer picture. And for the style loss, we have something comparable. You have a look to, for example, there is a star feature, for example, with the activation of 1. And in the style transfer picture, you can see such features again. This is a very, very easy description we are just speaking about. So if you want to know more about that, just maybe after the talk, we can hint you to a YouTube video where we are talking in much more detail. So, but demos are the best. So there were a few minutes we didn't have a demo. So let's try that. So I'm starting right now.
Slide.
Yeah, I know. At first, I want to discuss the pessimism and optimism by Giacomo Balla. Okay, yeah. So we trained on actually one of these machines. There is RTX 3080 Ti for 4 to 5 hours just with this one painting. And now, okay, yeah, there it is. And now we can do style transfer in real time. And back in the days, it just took 3 to 4 minutes to create only one picture. And here we are relying on pre-trained deep neural networks. And this is the reason why we can do that in real time. So of course we trained different styles. This is a very abstract one. So you can see that is, actually you don't see anything here. And this one is also interesting. So this is the Starry Night. Yeah, of course. And guess what this style is? What is it? The Scream by Edvard Munch, right? And what happens? What is that one? Yeah, Take On Me. Awesome. Yeah, the music video of Aha. We just took out the paintings of the Take On Me music video, the drawings, the pencil drawings, and we trained the neural network, and it looks like this. So back in the days, they paid $100,000 for the music video, and now you actually can enjoy that in stereo vision with the HTC Vive Pro, Thomas, right?
Absolutely.
Yeah, so now real-time deepfakes.
Real-time deepfakes. So let's get to the real stuff here. So what we are doing here is we have Harald Lesch, which is a famous German scientist who also happens to do some TV shows, and we have them in two times. We have him 2 times here on the left and here also on the right. And this is The reason, the reason for this is that there is a deepfake in here. And a deepfake, we can do this in real time. So we can change faces, we can swap faces out in real time. And we want to show you how we do this. So first of all, we have to, of course, grab the image from the camera. Then the next step would be that we have to identify the face. So you remember these HAR cascades? We are doing this as well, but now we are doing this in a way more elaborate style. And for this, we are using MediaPipe. And we have a demo for that, of course. There's always a demo. So here you can see Martin, and you can see 468 landmark points on his face. And these landmark points are basically just so they are just matched to his face. And with this, we have a pretty good impression of where the face is located, and we can just rectify that and use that as an input for the next stage, actually. So let's go to the next stage, and this is our so-called segmentation. So what we need to do now is we need to find every pixel in the face that belongs to the head. Yeah, and every pixel that does not belong to the head anymore, because up until now we had just this rough mesh on the head, and now we need every exact pixel here. And of course, we have a demo for that. So here you can see
I
Martin.
feel so sick.
Yeah, he's a bit bluish right now, so this does not result of oxygen, but we put the segmentation on him. So as you can see, it works pretty well. It is not perfect, so if Martin is looking to the side, it might break a little bit, but it works good enough. So we trained our own neural network to do this segmentation for us. So the next step is the most important one, because you don't want to break the illusion, and because I really don't like Martin's face. And this is the face where we eliminate the old face. So we are just extracting that and just removing the old face. So every pixel that belongs in there must be filled with something else. And we are doing this by just filling it with the surroundings, actually.
Guess what? I think it's time for another demo.
Yeah, I think so as well. So here you can see Martin, or you can't see Martin anymore. So he is filled with the surrounding. And you might say now that this is actually not perfect. Yeah, it is not perfect. So you might see that this is an illusion. But we don't need to be perfect here, because we are gonna put another face on this.
Yeah.
And this is the last stage of our deepfake. And this is where the real magic comes in. So now we need to replace Harald Lesch with Markus Söder.
The holy Bavarian king, but I would prefer this face here in this case.
Yeah. Me as well.
Yeah, but we should tell the audience how actually can you train a deep neural network that it can do something like that.
So let's see how this works. So here's some magic involved. So actually what we have here is a so-called autoencoder. An autoencoder takes a picture, brings that through a neural network, so it compresses the information that you get from the image through a so-called encoder, and then we have a representation of the face. So basically, are the eyes open? Is the mouth open? Is the person smiling? Things like that. You can find that in a so-called latent space. This is the one in the middle. And once we have that, we are taking the other way around and decoding the latent space again into the original image. And then, given the image, we get the exact same image. We just lost a bit of current electricity here. But the problem here is, how do we train that? And this is also pretty easy, because we can just do a pixel-wise comparison of the original image and the resulting image. And this is our cost function here. And then we have something which produces the exact same image from the image you get.
Yeah, isn't that awesome? You can just put in a picture of Harald Lesch, and Harald Lesch comes out.
It's awesome.
It's amazing.
Yeah.
Wow.
The real magic happens if you have two of these autoencoders. So one for Harald Lesch and one for another guy, Dirk Steffens. And what we are now doing here is we are just encoding the image of Harald Lesch, and then we have our latent space again, and we can then again say, are the eyes open, and so on and so on. But then we are putting this through a different decoder, namely the decoder of Dirk Steffens. And then we are recreating an image with the facial expressions of Harald Lesch, but with the face of Dirk Steffens.
And guess what? We have a demo for that.
Of course, we have the next demo. And here you can see the final deepfake. So unfortunately, lighting is not that good today. So normally it does not look that weird, but but in most cases you cannot tell the difference between Brian in this case and Martin. So you can also swap faces. Martin, you have to smile a little bit or do some crazy stuff now.
What if I put out the tongue?
Yeah.
Can you tell us why this weird stuff happens?
Yeah, the problem is that we we have training data, and this training data doesn't have a stuck-out tongue or something like that. So it never saw a tongue, and it just tries to recreate the best way it can, actually. So this is the problem. So if you have something in the training data, it will get recreated. If you don't have it, how should it be able to recreate that?
Yeah. So let's continue with natural language processing. Yeah, so NLP, it's a mixture of linguistics and computer sciences. And the question is, so we just learned how we can process graphical data, and but what about texts? This is the question. So let's assume we have here the sentence, computer science is so nice. And I hope you agree with me. And what we have to do right now, we have to tokenize this stuff. And so we just cut at each and every word, computer science is so, and so on. And then we assign to each of those tokens an ID. And as you can see, for the word so, it appears twice. And this means that you can see the token ID twice as well. And this is a very boring demo, but actually this is one of the basic functions how large language models are trained and how they are working.
Yeah, don't sell it like that. This is an amazing demo.
It's amazing. So let's have a look. Hello, Dev Days Europe. Nice to be here. So, oh no, it just holy.
It just took away all the characters, so we'll have to be a little bit more.
So yeah, we just do it like this.
Hello, audience. Yeah, that's okay. Also fine.
Hello, audience, and a dot. Actually, this is something which really happens. So tokenization doesn't mean that you cut after each and every word. So something like that can happen as well. This is, by the way, created with GPT-2, right?
This is a byte pair tokenizer, which is also used for GPT-2.
This is what I wanted to say. Okay, so let's move on with the. Now we have those numbers. You actually saw the numbers, and this is everything we need for our deep neural network, which we want to train. So here you can. You have the token computer science is so nice. We have the token IDs, and now we throw that into our deep neural network. So it is our input vector, and then things are going on, like we saw that for the face detection with deep neural networks.
And just a word of warning, don't use that for spam detection, because it's the totally wrong way to do this. This is just for illustration.
Just for an illustration, yeah.
In this case.
When we published the deep neural, the real-time deepfakes, there were some press coverage in the German media, and received a lot of threats, forum threats, and stuff like that. And they were really, how to say, mean. Yeah. And
mean.
here is a perfect example. Oh, the colleagues of TNG, the employees of TNG Technology Consulting.
No, it's not TNG Technology Consulting. It's
TNG it's just Consulting. TNG Consulting. They tape their cam from their notebooks with tape, and why do I know? Because everybody's doing that there. I'm still the opinion that we did the Amish people wrong. We don't know what this has exactly to do with our deepfakes, but our typical reaction is this one. Yeah, and we thought about that. So the time we are answering such troll posts, we thought, we made a design. We call it a shit posting jerk cycle. and there is the TNG gigachat on the one side and the troll on the other side. And we thought, wait, let's take out of that loop. So we just take an AI replying those troll posts, and and then the troll will be probably answer our troll post, AI troll posts. And then if you think a bit further, you can do everything with the AI. So we can work hard, party harder, and the troll can probably read a book about clean code. I don't know. So how did we realize the project? Yeah, with a generative pre-trained transformer, Thomas. So it's GPT. What does
GPT? So if you have not been living under a rock for the last 6 months, you've probably heard of GPT. And generative pre-trained transformer. So generative because we are using this to generate text. Pre-trained because it comes with the knowledge of the internet, so it's probably right all the time. And transformer, so this is the architecture that we're using. And for a transformer, there is some secret sauce in it, and this is attention or self-attention. So what we have here is, so you don't have the information that you need in your if you just have a look at the word he, for example. So it's a bit like cheating in school. So you have to look to the right, you have to look to the left, and then you just get some information. In this case, we only have the information from the previous sentences, so we're just looking backwards. And there we see the shit poster is mad, he. So we are now taking this information and we are weighing it, and we are just saying which of this information is really important for us. And we see that shit poster might be important, mad might also be a little bit important, and he is also very important for the word he. So we are taking this information and then we are using this to further analyze the sentence. So we are getting now the context, and we can now extract from this context the important information to get the next output token. So if we have a look to GPT as a black box, what we are doing here is we are doing a so-called autoregressive next word prediction. So what we are doing here is we are putting in, for example, computer, so the token for computer here, and running that through GPT, and there will be an output, and this is science. And then we are putting this back again into our input, running it through GPT again, getting out is, and so on and so on and so on, until we hit an end of text token. So this tells us that GPT is finished.
Yeah. And actually ChatGPT and everything like this, it just works like this. So it's not an AI which went crazy. So it's just basically next word prediction, auto-regressive next word prediction. So we trained, of course, with data where we expected the most shit posts. So the question is, where do we expect the most shit posts, Thomas?
I would say...
So you can guess if you like. Förtsch, okay.
Förtsch, okay.
Twitter, okay, good.
Twitter is good.
Yeah, actually, we use Twitter and Reddit, and one of the reasons was that we have an API where we easily can receive the data from.
But it's also a good source.
Yeah, it's a good source. And the thing is, we just didn't take all the data from Twitter and Reddit. We just have chosen channels where we just expected the most troll posts. So to name some examples: politics, change my view, unpopular opinion, shower thoughts, news, not the onion, and last but not least, political discussion, world news, and the best one, mechanical keyboards. Yeah, so how can we fine-tune a GPT-2? How can we train that it will create shit posts? It's easy. We have our input, for example, your deepfakes are shit. Then we take the prediction of GPT, and for example, here it says, your mom fakes are nice. Yeah? And what we can do right now, guess what? Coast function again. We can take the prediction of GPT-2, but we know what what we really expected. We expected your deepfakes are shit. So now we can make a differentiation between prediction and output. We expected, and you can see mom, deep, nice, shit, and so on. There is a difference We can put that into numbers, into a coast function, and we can train as long as needed so that GPT-2 will create shit posts all the way.
Yeah, and we did this for a very, very long time until we can now finally show you a demo again. So we'll start with an evergreen, I think. So one thing that has been in social media for a long time now, so something like COVID is a thing. And now?
Fingers crossed that the demo is also running.
Yeah, I hope so, but there are some good signs. Now I think you still need to create...
Okay,
yeah, it's starting.
You are the problem. It's not about you and I. The issue isn't that vaccines don't work and so on and so on. Sometimes
that
there's
one
some
is specifically
rubbish.
It will also create links which do not work, but which look like totally fine links.
Yeah.
It once created an iframe, and we did not know why there was something weird going on in our presentation.
Yeah. So this is a typical example of such troll posts, conspiracy theories and stuff like that.
At some point it will switch to Trump or something like that. This is totally normal. It
and
just replicates.
And there was a situation where we had to stop at the conference the output because it was too crazy.
Yeah, that basically replicates the internet.
Yeah, but of course there's more. So why did we use GPT-2? Yeah, the reason for that is you can just run it on your own laptop, on your own machine, no problem. This is not true for GPT-3, which is more powerful, of course, but you have to do remote calls for that, and this is not what we wanted. And of course, there is the even bigger brother GPT-4 now there. So for GPT-3, we have a live demo as well, and I don't know what shall I type in. Say
you
hello.
Should start the demo first.
Didn't I start the demo? No. Say hello to the audience here. So let's see what it is saying.
Yeah, you should actually ask some questions, but okay, that's okay.
Okay. What is the meaning of life? This is a classical one.
Probably you have tried that yourself by now.
Yes, of course. The meaning of life is to find out and fulfill the purpose and meaning of...
Actually, so this is GPT-3. So with ChatGPT, there are more powerful models available now. So, but as you can see, it can answer some basic questions.
Yeah.
It's okay.
Yeah. And I think the prompt was a bit biased by us. So, but it is another story. Yeah, let's come to the conclusion. So we asked the question, which path do we go? The red one, the yellow one, the green one? Winter, is it coming? So actually, we wrote this keynote 7 months before. And I felt we were more on the green to yellow arrow, but then ChatGPT was published. And I have to be very, very honest, what happened there, what was possible with this thing was quite crazy. We already had years of experience with GPT-3. It was published in 2020. And yeah, it's a crazy thing which is going on. So of course, you can make your own opinion about that, but yeah, we are somehow sure we are more experiencing a summer right now, an AI summer. And we have some business cases which we are already implemented, and we thought, why not showing this to you? And
the first one is actually something that you already saw, but in a different form. So when we had the deepfakes, there was something like a segmentation of the face. But you can also transfer that to persons. And now you can do GDPR compliant person segmentation. So yeah, not everybody is captured here. It has its limitations, but basically we are now just anonymizing every person that we see, or every person that the neural network sees in the picture. And this is going pretty well. And we had this also in a store for one of the security cameras, actually. All right, the second case is something it was basically a byproduct of all this stuff we are doing. So back in the days when we were doing things like GPT-2 or something like that, we were also thinking about, hey, what else is out there? And we came across a neural network which was called WMT19, and this is a translation network. And so we thought, hey, we don't want to use this Google Translate or DeepL anymore because this will leak our information into the cloud, and we don't want to do this. So we are creating now our own translator using just this neural network, and it worked pretty well. We created a Confluence plugin for that as well, so that we can now translate that, and which is now actually a store app. And this was pretty crazy because it was just one of these ideas we had at the innovation hacking team.
Yeah, right. And if we have a nearer look to the clock right now, you probably will see that we are running out of time, and that's perfect because we are finished with our keynote about what's possible with today's artificial intelligence. And we hope you enjoyed all those demonstrations and what's possible with AI today. And if you have any ideas or you want to discuss something, just come by to us. We are what?
I have an idea, pretty crazy one.
Which one?
But what if we take Eliza?
Yeah.
And mix and match that with GPT. So let GPT answer to Eliza's question.
Oh, this is interesting. So you want that GPT is just making some discussion with Eliza?
Yeah, actually, that would be great.
This would be great. So maybe we should start with that. Yeah, we should do that.
How do you do? Let's see what GPT has to say about that. Hopefully it has to say something. Hopefully.
It would be crazy if this is the first demo which is not working.
But actually it is.
Oh, yeah!
Let's try one more time because this demo is really good. Let's see.
Yeah. And I would say, Thomas, we just let this flow a few minutes and we say, thanks to you, thanks to the audience for staying with us, and
thanks so much.
Come home safe and everything, and thank you very much.